So previously, you guys learned about lines intersecting circles and the different types of lines intersecting circles. Today, we're actually going to be finding arc measures. Now, before you can figure out what arc measures are, we first need to define a few things. The first thing we're going to talk about are central angles. Central angles are angles whose vertex is in the center of a circle. Okay, so in the center of a circle. Now, the minor arc is when the measure of an arc is less than 180 degrees. The major arc is when the measure of an arc is more than 180 degrees. A semicircle is when the measure of an arc is exactly 180 degrees. So let me kind of draw a diagram here to kind of explain that. So we have a circle, not a really good one, but it's fine. All right, so here's the center of the circle. Let's call this circle C, okay? Now, a central angle is always going to start, the vertex of this angle is always going to be at the center of the circle, all right? Now, let's say that this is A, B, and then D out here, okay? So basically, the minor arc would be arc AB right here, okay? That's the minor arc because that's less than 180 degrees, right? Let's pretend that this is actually drawn to scale. So this is less than 180 degrees. Now, the major arc would be this one on the outside here, right? So this would be, we would call this ADB. We would have to include the outside point, right? So this would be the major arc ADB, whereas the minor arc would be AB. Now it would be a semicircle if it was like, for example, let's draw another one. So if it looked like this, that would be a semicircle. Let's call this D. This would be a semicircle because it is 180 degrees. Okay. So let's look at finding arc measures. So basically, the way that you're going to find arc measures is the arc measures is always going to be the same as whatever the corresponding central angle is. So if we look at arc measure RS, arc measure RS is just going to be 110 degrees. Okay. Now, if we look at RTS, so RTS, that's going to be 360 degrees because we know that a full circle is 360 degrees, right? So we're going to do 360 degrees minus 110, and that is going to give us 250 degrees, okay? So that's what this whole measure of this angle is. Now, this would be considered a major arc because, again, it is greater than 180 degrees, whereas arc RS, would be considered a minor arc because it's less than 180 degrees, okay? Next, they want us to find RS, so RST, so that's this angle here. I'm going to use a different color. So RST. Now, as you can see, RST goes through so it starts at the end point of the diameter of the circle. So we know that a diameter is a straight line, right, that goes through the center of the circle. So that's going to be exactly 180 degrees. Okay, let's look at example 2. So for example 2, it says to find the measure of each arc. All right, so once again, we're going to do the same thing. So we're given a circle, and then we're given different angles, right? So the first thing we want to do is we want to find measure of arc GE, okay? So they're only using 2 letters here, which means that they're talking about a minor arc, right? So GE is going to be 40 plus 180, okay? So 40 plus 80. Did I say 180? I meant to say 80. So 40 plus 80. That is going to give us exactly 120 degrees. Okay? Now, GEF, right? I'm going to go ahead and erase this. All right, so GEF. If we're looking at GEF, that's this angle here. Okay, we are going to have to add up all of the sides, right? So we're going to do 40 plus 80 plus 110 because, again, it includes all three angles, right? So we would just add them up. So if we add that up, that's going to be 230 degrees. Okay. Now, for angle GF, that's right here, for angle GF, or for arc measure rather, GF, that's going to be this portion here. Now we know that the measure of the angle of an entire circle is 360 degrees. So we're going to do 360 minus 40 plus 80 plus 110, which we already found that the sum of those angles is 230 degrees. So I'm just going to subtract that from 360 degrees. Ooh. Sorry. And that is going to give us a measure of 130 degrees. All right. So just to kind of sum up what we talked about so far, what's very important to note here is that the central angle always corresponds to, it's always going to be the same as the arc measure. Now, later we're going to be talking about inscribed angles. That's going to be completely different because for an inscribed angle, we know you're going to find out that the vertex is actually going to be on the circle. So please make sure that you understand that it's only the same if it's the central angle. All right, so again, the central angle always corresponds with its arc measure. Okay, so the next thing we're going to be talking about is the congruent central angles theorem. This states that in the same circle or in congruent circles, two minor arcs are congruent if and only if their central angles are congruent. So these two arcs are going to be congruent if their central angles are congruent, right? And this would also occur if you have two congruent circles with congruent arcs. So let's look at example A. So it says, tell whether the red arcs are congruent. Explain why or why not. So if we look at arc measure, so if we look at arc CD and EF, those are going to be congruent because, as you can see, they are in the same circle, right? And they have congruent central angles. Therefore, CD, so arc CD and arc EF, have to be congruent. So yes, because the central angles are congruent in the same circle. Okay. All right. Now, if we look at question B, we can see that both of these, we can see that there are actually two circles here, right? There's the outer circle, and then there's the inner circle. So both of them are 90 degrees, but the problem here is that they are actually two different circles. They're not congruent circles. So because they're not congruent circles, then these two arc measures, RS and TU, are not congruent. So no, circles are not congruent. Therefore, the arcs are also not congruent. Okay, so let's look at C. So on part C, we can see that these are two circles that are congruent. The way that we know they're congruent is that they tell us that the radius are the radii here are the same. So because we know that the radii are the same, then that means that these two circles must be congruent, right? So we also know that both angles are congruent. They're both 95 degrees. Therefore, the corresponding arcs have to be congruent. So yes, circles are congruent.